Alright, last video of chapter 14, 14.11. Here we're looking at the Lewis acid-base model, revisiting the Lewis acid-base model. I'm going to talk more about that. So just a reminder, Lewis model, think about Lewis dot structures, we're talking about electrons, so that's kind of the key here. And remember their definition of acid-base is the opposite of Bronsted-Lowry. A Lewis acid is an electron pair acceptor, where a Lewis base is an electron pair donor. So things that have electron pairs typically have the ability to be shared. Lewis acids want them, they're kind of deficient. Here's boron deficient of a pair of electrons, it'll share them, and you make this complex over here. So it's a Lewis base, Lewis acid reaction you're seeing here. Here's a couple examples. Goal here is to draw Lewis structures to kind of demo this being happening. So HCl would be H bonded to Cl, and it has lone pairs of electrons around the chlorine like so. Here we actually need to add water to make this kind of work out. And water would look like this, bent shape like so. Okay, so what happens is, hopefully you know this is an acid, hydrochloric acid, right? Yeah. Water's acting like a base here. What's going to do is going to donate a pair of electrons, and we know that when it acts like an acid here, we know it's going to produce H3O plus, right? I mean, we know that's coming, so let's kind of make some predictions here. Cl dot 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 minus. Let's kind of make a prediction here. So what happens is these pairs of electrons are going to be donated to the acid here. And going back to the definition quick, Lewis acid is an acceptor. So here's our acceptor. It's accepting those pair of electrons, and it's going to make a bond with the hydrogen. So it's going to make this bond right here perhaps. By the way, this is positive, and we should put brackets around that. Brackets around this too. But it makes a bond with that hydrogen there. And now you have your H3O plus. What happens is these pairs of electrons are being shared here. They actually just take themselves and put themselves right on the chlorine. And now they are these pair of electrons right there. And the base was the electron pair donor, and the acid was the electron pair acceptor. We are not going to go into this great depth of Lewis acid model in our class, but I just kind of want to show it to you. This right here, essentially what you're seeing, this is organic chemistry, also called orgo to the people in the business. And our last one here, this really shows why these metallic oxides are acidic. So aluminum chloride and water will dissolve to produce Al3 plus and 3Cl minuses. But what ends up happening is the aluminum ion has acidic properties, and here's how it does it. So aluminum ion 3 plus will react with water. And we talked about how highly charged metal ions are acidic, so this is the acid, this is the base. And what happens is, bases are electron pair donors. It's going to donate its pairs of electrons to this highly charged metal who's positive, kind of an acceptor because it's positively charged, likes to accept negatively charged electrons like this. But it turns out this aluminum is going to take on 6 waters who like to do this. And when it does this, it's going to create what we call a complex ion. So aluminum is going to, in a octahedral arrangement here, all 90-degree angles there, it's going to have some waters around it. So it's going to be H2O. H2O, I'm going to write it this way so it's a little easier to show how the oxygen is the part that kind of donates its pairs of electrons or shares its pairs of electrons here. H2O, H2O, H2O. And now we've formed a complex ion, and one thing we typically do here is we'll put that in brackets and 3 plus it like this to show it's a complex ion. Then what happens is this complex ion here, which we'll call Al, H2O, 6 overall charge 3 plus, it'll go on to donate some electrons, or so to donate some hydrogens by turning into Al, H2O, 5, and then we'll say OH left here, and plus hydrogen. So what happens is, one of these water molecules, I'm going to turn this into this hydrogen is lost and becomes this right here, and then here's your OH that's left over on the end right here. So, wow, that was a lot. But highly charged metal ions, so aluminum chloride dissolves into aluminum ion and chloride. Aluminum ion, highly charged, is an acid because what it does is it bonds with some waters, 6 of them to be exact in this particular case here, And when it does that, it loosens the hold on the hydrogen here we're looking at, and then that hydrogen gets donated, and therefore it's donating acid, or donating a hydrogen, so therefore it acts like an acid. And this is our Lewis acid model showing how that goes down. Good stuff, huh?